Hello everyone, I am Dr. Pranit. I'll be teaching chemistry today. This will be second part of the second chapter of the chemistry, that is structure of atom. I'm excited to connect with you through the Knowledge Temple platform, a dedicated platform providing quality education and mentorship for the student across India. You will be getting structured learning and live lecture, mock test and perform based rewards. Okay. So today this will be second part of the second chapter. Today we'll be starting off with the atomic models. Today we'll be learning about the Thomson's model of the atom and the Rutherford model, which is one of the most famous thing about the chemistry. Also we'll be learning about the atomic number, mass number, what are isotopes, what are isobars and what are isotones. Okay, so let's get started. First let's learn about the Thomson model. Thomson is one of the most important personality in our chemistry point of view. He studied an atom in a very different perspective. He studied atom based on relating an atom model to a watermelon. He related atom as a watermelon consisting of seeds in it, and he explained that seeds are nothing but the negative charge particle in it, and a whole watermelon is a positively charged in it. Okay, he considers that atom consists of a positively charged sphere with uniform distribution of the electrons. Okay. Now the Rutherford model stated that when an electric charge is passed through it, this goes straight and undeviated without any deflection. Okay, he made a setup in which he bombarded an alpha particles from a source of a lead box, in which he made a gold foil in which they made incident the alpha particles, and a deflection screen was made behind it so as to see whether there is a deflection of the rays or not. According to the Rutherford model, the observation was made, and he made the observation that most of the alpha particles went undeflected. Few alpha particles deflected by the small angle, very few alpha particles deflected backwards. So here he came to the conclusion that if there is no deviation, that means there is no change in the direction, that means there is no opposition in the direction. According to the Thomson model, it went undeviated, but according to the Rutherford model, he said that there was slightly deviation in the direction. Some turns backward while some change the direction by few alpha particles deflected by small angles. Okay, so the conclusion drawn by the Rutherford was that atoms have a lot of empty spaces. Firstly, he concluded that atoms have empty spaces in it. Secondly, he made an atom have a positively charged entity. He also made to the third conclusion that a positive charge entity is present as dense mass at the center, and dense mass is very small and is known as the nucleus. He came to the conclusion that there is an atom is having lot of empty spaces. He made that suppose this is an atom, he has lot of empty spaces in it. An atom has a positively charged entity in it. He said that there is a positively charged entity at the center of the atom, and that positively charged entity is present as a dense mass. When he said that it has a certain mass in it, and this dense mass is very small and is known as the nucleus. So he also conferred the size of the nucleus and the size of the atom. The size of the nucleus is 10 raised to power minus 15, and that of the atom is minus 10. So the nuclear model of atom was positively charged mass is located at the center and is nucleus. The electrons are there in circular path, which is known as the orbit, and the force which revolves around this is electrostatic force, which are held together by it. Suppose we consider as an atom, these are the orbital path in which it moves, and this is the nucleus. So for example, this is an electron revolving around it, there should be certain energy which makes it revolving around it. So this energy is nothing but the electrostatic force, and these are your electron, and these are the orbitals. Now there are certain limitations of the Rutherford's theory. The Rutherford's model explains stability of the electron in orbit is not mentioned, distribution of the electrons was not explained, and atomic spectra was not explained. Now let's talk about the atomic number and atomic mass number. The atomic number purely consists of the number of protons. Okay, whenever we talk about atomic number, it is only the protons. But when we talk about atomic mass, it is the number of protons plus neutrons. Okay, so now the denotation of the so the denotation of the element is X is A and Z. So A is the atomic number, mass number, and Z is the atomic number. So now let's learn what are isotopes, isotones, and isobar. Isotopes are two compounds which are having similar compound having equal number of protons, but isotones are having equal number of neutrons, and isobars are having equal number of mass. So here we can make a trick. As we can see here, it has P, so it has equal number of protons. Here in isotope there is a N, means it has equal number of neutrons, and isobar has a mass. Now let's go through this question. Two nuclides of A and B are isoneutronic. Their atomic masses are 76 and 77 respectively. If the atomic number of A is 32, find the atomic number of B. Okay, so what they have given, first you have to note it down. First they have given us A and B are isoneutronic. Okay, so there we have given atomic mass number, atomic mass. So atomic mass means A of A is 76 and A of B is 77. Okay, if the atomic number of A is 32, so atomic number of B is how much? Okay, so now neutrons is atomic mass minus atomic number. Okay, so now we can say atomic mass of A was given as 76 and they have given atomic number as 32. We will be equating both, in which here it is given 77 minus X. So here it comes as 76 minus 32 will be coming as 44, and here it will be coming as 77 minus X. So X will be 77 minus 44, which comes around 33. So X of B will be 33. Now let's take this test. Here they have given calculated number of electrons in which they will be have together weigh 1 gram. So 1 gram they have given mass. So I just want you to take a pause and solve this question. So here they have given the mass of 1 gram. So as we know, mass of 1 electron is 9.1 10 raised to power minus 31. So number of electrons that is 1 gram will equal to 1 by 9.1. It comes across 1.098 into 10 raised to power 27. So up till now we learned about what is Thomas model. We explained it in the former related with that of watermelon model. Then we came across the Rutherford model, that is the alpha particle scattering experiment. Then we learned about the atomic number, which is the number of protons in the nucleus in an atom. Then we learned about the number of electrons in the neutral atom. Then we learned about what is atomic mass number. Then we learned what is isotopes, isotones, and isobars. Okay. I hope till now you are clear with what we have taught. I just want you to go slowly with this chapter, as we know that this chapter may seem like a theoretical part, but it is the main foundation of learning the chemistry of grade 11 and also grade 12, because many things are based on what we are learning till now. So I just want you to go slowly and steadily. So we'll stop till now. I hope you guys are okay with what we have learned today. Thank you for watching this lecture. I hope you liked it, and you can join us in Knowledge Temple for complete learning live classes and mentorship. Together, let's make learning engaging and rewarding. Thank you.